Saxon Algebra 2. This is lesson B, the last of our weird alphabet lessons, and then we'll switch back over to numbers. This is another, it's even bigger than A, you guys. It's a massive review lesson. So again, John starts us off with an avalanche of information, and we're going to quickly settle down into a more manageable pace. So bear with me as we plow through another beastly heap of topics. This one again is mostly geometry. We dabbled just a little bit in algebra last time. Remember, we did the exponents and the absolute value. But this time we're going to just plow through a whole lot of geometry concepts. If I'm going too fast, if you want to look at this in a little more detail, check out the lesson in your book for lesson B, and you can get more details and a sort of a slowed down presentation. All right, let's dive in. Perimeter. The perimeter is the outside edge of a polygon. Okay, a polygon, remember, is an object with straight sides that's closed, that doesn't have any intersecting lines. So this is straight lines, right? A perimeter is made up of straight lines. And then we have another word that kind of means the same thing. Circumference. That's the outside edge of a circle. So it's just a curved line. So two different words that mean the same thing for different shapes, all right? Now, when we talk about circles, since we're gonna dive right into talking about circles, we wanna define a couple different words. From the center to any point on the edge of the circle is called the radius. Right? From the edge of the circle to the center and straight on through to the edge again, oh, pretend it's perfect. That's called the diameter. And we can say that the diameter is equal to 2 of the radius, or radii, if you want to be plural in the right term. And so that's a cool thing. And then there's a third thing. I don't even want to put it in my picture because we really don't use this idea that much, but I'll show you. Here's the radius, right? Here's the diameter. A chord is a line that goes from edge to edge of the circle, but not through the middle. Because it's not as precise as either of these, we don't use that one as much. But that's a chord. All right, so the ancient Greeks were fascinated with radii and diameters, and they wanted to come up with a formula for finding the circumference. And what they found is that sorry, I'm getting distracted in reading this. If you want to find the circumference of a circle, it's equal to 2 times the radius times this cool number called pi. And pi is roughly equal to 3.14. It's got a ton of decimal places, infinite decimal places, but in high school we round that to 3.14. In my college math classes, we rounded it to 4 digits to make the calculations a little more precise. But in high school, we're going to keep it at 3.14. So whenever we see this symbol, we can either leave that symbol in our calculations or we can multiply it out by 3.14. All right? So John spends a lot of time showing how that is used. This is called an irrational number because it has infinite, non-repeating decimals. We're going to talk about irrational numbers much later in the year, and we will use pi as a great example of an irrational number because it is infinite non-repeating decimals. Okay? All right. That's what I have to say about circumference and perimeter. Now let's switch over to area. Area measures in 2 dimensions, okay? Perimeter and circumference measure just 1 dimension, not 1 direction. That's different. We are a 1D household. I know the time has kind of come and gone, but my daughters were all about the 1D. Okay, but area is 2-dimensional. And again, we can talk about it in terms of polygons, right? We can measure the area of a rectangle. And if this is the length of the rectangle and that is the width, I make that like a little cursive L because if I made it a printing L, it would look like a 1. We can find the area by multiplying the length times the width. You probably started doing that in like 4th grade. If we want to find the area of a circle, so this is another way I would write this. Gracie's barking in her sleep. If we want to find the area of a rectangle, it's equal to the length times the width. With a circle, area is equal to pi r squared, r being the radius, right? So the area of a circle equals pi r squared. All right? These are super important formulas that you want to keep track of. Now, here is an idea that I'm going to repeat to you many times this year. In order to remember formulas, you have to have them close by. You need to memorize them, but you know, who wants to devote a portion of their life to memorizing formulas? I bet you don't. So here's what I recommend. Take the cover of your math book, the book that you do the homework in, and use that as a place to record all of your formulas. The book that I'm using at the moment has a cardboard cover front and back. Some have plastic covers and that obviously doesn't work, but I would just write area of a rectangle equals length times width. Area of a circle equals pi r squared. And then I would write circumference of a circle equals pi 2r. Okay? Now, when I'm doing my homework, I've got my information right there, and all I have to do, I'm working away on my homework here, right? And I'm like, dang it, what's that formula again? I flip, there it is. Sooner or later, you're gonna memorize that, and I'll tell you why. Because it takes a certain amount of effort to flip from here to there, and you're gonna get lazy. I mean, I do too, you guys. It's not like I'm shaming you. But sooner or later, we get to the point where we're like, ugh, I don't even want to flip back to that page. I'm pretty sure it's pi r squared. I'll try that and see if it works. And you will find that you have memorized them. So write it in your book. When this homework book fills, you're going to have to copy them into a new book. But that's okay. That's another great way to remember. Okay, flipping. We're talking about area still. Guess what? Now I have another pet that wants out. Isn't this fun? This is my cat room. Here, Wonton. Out you go. Come back safe, little man. Okay. My pets are like the commercial breaks in our presentation, right? A constant distraction. Okay, triangles. The area of a triangle equals base times height divided by 2. So let's write that in your book right now. I don't want to flip because I have to check every time to make sure I'm still in the camera range. But take a minute right now and write that in the cover of your book, wherever you like. I'll wait while you do that. I'll yawn while I do. And in this, now that you're back, I want to remind you that it doesn't matter whether you have a right triangle or an acute triangle or an obtuse triangle. The height is measured, this is the best way I can explain it, you guys. Pretend there's a little spider that climbs up to the tallest point of your triangle. Okay, this is the spider test for finding the height of a triangle. The little spider climbs up. My spiders only have 6 legs. Real spiders have 8, but that's okay. They climb to the highest part of your triangle and they drop a line straight down. That is the height of your triangle. So with a right triangle, it just happens to fall on the outside edge. If you have this kind of triangle, when he drops it straight down, right, and it makes a perpendicular with the bottom, that is the height. So as you can see, it doesn't necessarily have to be a side of the triangle. It can be this line through the middle-ish, doesn't have to be the exact middle. And this guy, this is the weirdest one of all, right? This dude's line falls outside the triangle, but that's still the height of the triangle. So when you're trying to find the height of the triangle for this calculation, give it the spider test, all right? The base is relatively easy. It's what is at the bottom. So there's that. Okay. Dun, da, da, da. So now we're going to use this information and these crazy problems that can be such a headache. But we are given a weird shape. It goes like this. I'm copying it out of the book as best I can. You can copy it off my paper. We're told to find the perimeter and the area of this circle. Lines that look parallel are parallel, dimensions are in meters. Okay, I'm just gonna write that down over to the side, and I'll remember at the very end to put an M by my answer to say that it's meters. Okay, we have to find the perimeter and the area. Ay, ay, ay. Let's find the perimeter first. So what I do is I'm just gonna pick a starting place. I'm gonna pick right here, where the semicircle. Okay, let me just talk about that. It helps if we can visualize this diagram as being made up of 3 shapes. That's gonna become really important when we get to the area. But for now, it helps just a little bit as we visualize this. So I'm gonna start measuring my perimeter here. I'm gonna go around clockwise and add up all the different sides. So I start with 4 plus 5 plus 7. Now I need to find the perimeter of this half circle. Well, shoot, how are we gonna do that? Aha, I remember perimeter in a straight-sided object is the same as circumference, and we have a formula for that. The circumference equals pi times 2 times the radius. But that's for a full circle, right? I only want a half circle. Notice how I draw a circle and coloring half of it. So if I want half the circumference, I can take my regular formula and divide it by 2, right? Because I want a half circle instead of a full circle. That's very cool because what that does, if I simplify it, those 2's cancel out. So the circumference of a half circle is equal to pi times the radius. And that's so valuable that you might want to just take a minute and copy that into your front of your notebook right now. Okay, to lock that in. So I know that I have to add to my perimeter calculation, I have to add the radius times pi. The radius is 2 and pi is 3.14. So remember, parentheses can mean multiplication. So I need to add that total to get the circumference, and that takes me back to where I started. So those are all the pieces I need to add up and get the perimeter. So now I can add that. I'm gonna add these 3 together. 4 and 5 is 9, plus 7, that's 16, plus, and this is 6.28, right? I multiply the 2 times the 3.14, and that gives me a final answer of the perimeter equals 22.28 meters. Make sense? Yay, we got it right. All right, so all of that, you guys, and that's only half the problem. Oh, my word. Okay, so I'm gonna go over here now and I'm gonna do the area. Okay? Now, when I'm approaching the area, that's where it becomes really important to consider these three different shapes. So I'm gonna find the area of the half circle, and I'm gonna give myself a little room because that's gonna be more complicated. I'm gonna find the area of that rectangle in the middle, and I'm gonna find the area of this triangle. Okay, I've got formulas for all three of these things. They're written inside my covers. One's right up there. So I've got all the tools I need. I just have to go through and calculate each one. Area of the half circle. Okay, I take the area of a circle, it's pi r squared, and we divide it by 2. Now notice that in this case, my formula doesn't simplify. There's nothing I can do for that. So this is going to be a little bit messier. So it's going to be pi times the radius squared. My radius is 2, so 2 squared is 4. And then I'm dividing it by 2 because I only want a half circle. Right? Okay, so that's why I'm dividing by 2, so I get half. Now I've got a cute little simplification because these guys simplify. And it comes down to just 2, right? 4 divided by 2 is 2. So there's 2 pi is my final answer. I already multiplied that once. It's 6.28. So 6.28 is the area of this little semicircle. All right? Now we need to do the area of this rectangle. Area of a rectangle is length times width. Now we have to figure out what's the length of this triangle, or I mean the rectangle. I know that 7 is this full length, but because these lines are parallel and I know that these make right angles, I can say that this much must be 4, and then that leaves this much to be 3, because they have to add up to 7, right? So I know that one side of this triangle has to be 4, or not triangle, square or rectangle, whatever it is. I don't know if they're going to turn out to be the same. So that equals 4 for the length. And now I need this dimension. I can't get it from this 5 because the length of this angled side has nothing to do with this. This is where it's going to be helpful because I know that the radius is from the center to any point on the circle, or half circle in this case. So from here to here, that must be 2. And then from here back down, that must be 2. So this tells me that this dimension, this line, has to be 4 as well. So 4 times 4, this turns out to be a perfect square. 4 times 4 is 16. Fabulous. Okay, now we're on to the triangle. The area of a triangle is the base times the height divided by 2. The height, remember, we find by the spider climbing up to the top and dropping down. The base, in this case, we already figured out is 3. The height, here goes the spider up to the top, drops the web straight down. Okay, that's this line. And we know from over here that this line has to be 4. So it's 3 times 4 divided by 2. I simplify. 4 over 2 reduces to 2. 3 times 2 equals 6. And now I'm going to add up because I'm out of space going down. I keep in mind my decimals. So it's going to be 0.28. I know that. 6 plus 6 plus 6, that's 18. So it's 28.28 meters squared. Area is 2-dimensional, so I square my unit, and that's the right answer. Whew, that was a long problem, wasn't it? And that was all one problem. I know, I don't think it's fair either. I think John went a little crazy when he designed these problems. But we'll be doing a lot of those, you guys. All right. Here's another one. This is a specific kind of problem that shows up a lot on placement or standardized tests because they look really hard, but if you know how to do them, they're really easy. But here's the thing, you guys. I am almost certain, but that by the time you get to college enrollment days, you're not going to have to worry about taking the SAT or the ACT. I just have a pretty strong feeling they're going to be gone away by the time you get there. So I used to always tell students, you'll see these on the SAT, but I don't think you're going to take the SAT. We'll see. But here's what's interesting about these problems. They have a shaded region. The area outside of the shapes, but inside of this box is all shaded. What does that mean? Here's the way I want you to visualize this. And I bet you've done this before, but if you haven't, just imagine with me. The overall rectangle is a piece of toast. Pretend it's perfect. It's a piece of toast. Your mom made it for you. She buttered it. She put your favorite topping on it. Mine would be peanut butter. And she gave it to you on a nice little plate to eat. What you do is you pick it up, you fold it in half, you take a bite out of the folded side, and then you open it back up again, and there's now a hole in your piece of toast. You fold it again and you take another bite, and this time you bite it in the shape of a triangle because you have gifts and talents for doing such things. So imagine this as a piece of toast with 2 bites out of it, and that will help you remember how to do these problems. We're supposed to find the area of the shaded region. What we're going to do is we're going to find the area of the overall piece of toast, and then we're going to measure your bites. And then we're going to subtract the bites from the piece of toast, and that will tell us the shaded region. Okay, so whenever you see a shaded problem, think subtract. Okay, that's the key to solving this kind of problem. So I'm going to draw myself a little roadmap over here. We're going to take the area of the big rectangle, and we're going to subtract the area of the circle, and we're going to subtract the area of the triangle. Okay, so this is a map that's going to help me work through this problem. So this one, the last one I did was really squished, and I don't like the way it looked. This one's going to look nicer. So now this helps. This is my roadmap. Now I'm going to put in formulas. Area of a rectangle is length times width. Area of a circle is pi r squared. No half circles this time. We don't have to divide anything in half. The area of a triangle is base times height divided by 2. So I start with my general idea. I put in formulas. Now I'm ready to do the actual calculations. The length and the width of the rectangle. Don't let it confuse you which is which. Length is usually the longer edge. Width is the shorter edge, but it doesn't matter. As long as you get the 2 different numbers, you're fine. 15 times 10, and then I can multiply that through 150. All right, let's go to our circle. Pi r squared, r, the radius equals 4, so that would be 3.14 times 4 squared, which is 16. I'll write 4 squared up above it, but I'm just going to write my answer there. That's just so you know how I got it. Okay, so I'm going to have to multiply that through. I'll do that in a minute. Let's go ahead and do it now. 3.14 times 16. Remember, you guys, when we do a multiplication like this, P.S., we never use calculators in this class. Unless I give you specific and explicit instruction, no calculators. We are working out our brains. We want to stay fit in our ability to do simple math, and so we don't rely on calculators. They make us lazy. So we always do all our calculations by hand. Okay, and so they're part of the problem. Don't feel like you have to erase them or squish them over on the side. Don't be ashamed of them. Just show them as part of your work, and it's fine. Okay, 6 times 4, 24. 6 times 1 is 6, plus 2 is 8. 6 times 3, 18. If you were with me, you would be doing all the multiplying, and I would just be writing it down. Okay, we put a 0 here because we're shifting over to multiply by what's actually 10. 1 times 4, 1 times 1, 1 times 3. Now we add 4, 2, and we put in the decimal place. Remember, the rule is we count how many decimal places we have in the original factors, and we add that many decimal places back to the number. So it's 50.24. And as I write this down, I'm going to try to line it up so that my decimals are fairly neat as I go over here to add. Because remember, when we add decimal numbers, we want to align the places. Okay, ready for our triangle. The base of the triangle is 5. The height of the triangle, okay, I'm going to draw in the spider. There he is, Spider Sammy. And okay, that goes straight down here. So the height is 6. Divide it by 2. And 6 over 2 cancels to 3. This is 15. Okay, my columns got a little wonky, but you can sort of see this as a table where I did roadmap, formulas, calculations, and answer. Make sense? So as you work these problems, I want you to very neatly organize your work. And then the final answer will add these together. Oh, we're subtracting. We're subtracting. We're not adding, right? We're subtracting. So 150, and again, I'm going to do the work. I'll do it up here. 150 with decimals minus these two, right? We're subtracting them both. So that would be 65.24. Subtracting. Oh boy. We've got a lot of borrowing or regrouping to do, whichever word you learned. 6, 7, 4, and this is actually 14, 8. So our final answer is 84.76. Look for our unit. In the book it says dimensions are in meters. And it's area, so it's squared. That's the right answer. So this is the area of the shaded region. It's the toast you have left after you take those 2 bites out of it. All right? Again, that is a really long problem, you guys. Granted, I use a lot of space, but seriously, the whole page, that's nuts. All right, and guess what? We're not done. We have pages to go. Oh, this one is a murderous lesson. Flipping. Okay, next topic, volume. Here's the good news about volume. One formula fits all. We find the area of the base, volume equals the area of the base times the height. Write this one in the cover of your book. This one's nice because one formula works for all different kinds of shapes. You just find the area of the base. It might be a circle, it might be a triangle, it might be a rectangle, it might be a combination, but you just figure it out and then multiply by the height and we're good to go. There's a lot of information here about the different types of geometric solids. I don't want to get too carried away with all of that. Let's do the examples and I'll explain what you need to know. I don't want to overwhelm you with any extra information because your Jenga tower of a brain has got to be rattly. Okay, The first problem has a complicated picture that I'm not going to try and draw, so let me show you in the book. Find the volume of this cylinder. The area of the base is 242 meters squared. And then we look at this and we see, oh my gosh, it's got this crazy shape and it's all tippy, and I want to quit math. I don't want to do this anymore. It looks too hard. But guess what? It's actually super easy. The formula that we need is area of the base times the height. Well, here's the area of the base. They already did it for us. And here's the height, right? Even though this is tippy, we measure the height is just straight up and down. It's like the spider thing again, right? So all we have to do is take this number, the area of the base, and multiply it by the height, which is that number. Okay, so look. We're using this formula. I'm going to use my abbreviation. Area of the base times the height, okay? The area of the base, we are told, is 242 meters squared, and we are told that the height is 10 meters. So all we have to do is multiply. That's it. We're done. Even though that picture looks so hard, because John is giving us the area of the base already calculated, it's a piece of cake. Okay, let's hope they're all so straight and simple, right? B4. And again, this one is too complicated to try to draw. Find the volume of this cone. Ah, it's a cone. What does he mean by that? Oh, look, the base is big, but it all comes up to just a single point. That's what he means by a cone. So it doesn't have straight sides. It's whittled down. The area of the base is, oh, look, it's the same base as that one. All right, and it's the same height, 10. But this time, it's a cone. So I have a, whoops. I have a simple adjustment to make to this formula. The volume of a cone equals 1/3 times the area of base times the height. So essentially what we're saying is that we're whittling away. A second, it needs parentheses around it. We're going to whittle away some of that shape because it's going up to a point, right? So let's take a simpler shape. Let's say that we have a cylinder, just a simple cylinder with a solid bottom. This shape, if we turned it into a cone, see if you can see it that way, right? Can you see how there's a cone inside of that cylinder? When we're whittling away all that extra to just shape it down to the cone, we're getting rid of 2/3 of the volume and only keeping 1/3. So that's why we use this. I call it a whittling fraction. We're whittling away a lot of the extra material that would be in the cylinder so that we just get a cone. So in this case, we have the same information as before. So the volume of our cone is going to be equal 1/3 times 242, which is the area of the base, right? Times the height, which is 10. So we can say it's 2,420 divided by 3, right? I just squished this all together. And then let's do the division on that. 2,420 divided by 3. So now we're going to practice long division. 3 goes into 2, not at all. 3 goes into 24, 8 times. Exactly. That's always a good omen, right? We subtract, we bring down. 3 into 2, no, so we have to bring down both. Okay, now shoot, this isn't going to work out because it's not 7. I mean, 3 times 7 is 21. It's too big, so we have to go with 6. So I'm going to put a 0 here and a 6, 18, and look what happens. We just keep getting 6s, 18. and it's repeating. So I'm going to round this to 2 decimal places. I'm rounding it up because it's 6s forever, right? So the 6 rounds up to a 7. And so I'm going to say that the volume of our cone equals 806.67 meters cubed. Volume is 3D. Okay, so we always put a cube on our unit. All right, that looks frightening, but it's still not that bad. Make sure you put this adjusted formula with this one in the cover of your book. And then we have one more. One more example, but we're still not done with the lesson. I know. I'm crying too. This time, again, I don't want to try and draw it perfectly. We have not a cone, but we have a sphere. And John drew the picture this time. Remember how I drew it like inside of a sphere or a cylinder? John did this one. So we can see we're going to have to whittle again, right? If we take the formula for this basic soup can shape and we whittle away some of it, just like we had to whittle away for the cone, we will get down to our sphere. This always reminds me of a, you know how tennis balls come in those cans? It's like a single ball can, a single serving size of tennis balls. So we have to do the same thing. We have to use a fraction to whittle away some of this space that we don't need because we have a sphere instead of this whole container. With a cone, we used 1/3. With a sphere, we use 2/3. Okay, so let's write that down. The volume of a sphere equals 2/3 the area of the base times the height. The cone was 1/3. That makes sense because a sphere is bigger than a cone, so we don't whittle away as much. We keep 2/3 this time. But it works the same way where we're just going to find this information and whittle. So let me try and draw the picture. Here's our sphere. It's our tennis ball inside the can. This is to help you see the 3-dimensionality of the sphere. Then it's packed tight into this can, right? I'm going to try and draw it perfectly. Right, so this is touching on the bottom of the can. And then this is touching on the top of the can. Those dots are there just to help you kind of visualize the way it's squeezing in. The radius, which goes from the center of the sphere to any point on the edge, that's the radius. And then the height of the can is 2 times the radius. Well, that kind of makes sense, right? Because the radius would go straight up and straight down. So we don't have any numbers yet, but when we look at the instructions, it says find the volume of the sphere whose radius is 3 centimeters. Oh, the radius is 3. Okay, that's a nice little number. I like it. So now we have to do a little bit more work in this problem. We have to find the area of the base, right? So the area of the base, well, it's a circle. So that we know is pi r squared. Okay. R squared. So that is equal to, let me just put the actual numbers in. It's 3.14. The radius is 3, we're told. That was given to us. So r squared would be 9. Okay. Whew, we're getting there, you guys. So now we need 3.14 times 9. $36, 12, 27, 28. Okay, so the area of the base equals 28.26. Notice I'm not putting units on anything. I'll put those on at the very end. All right, the area of the base equals that. Just a second, I'm looking at the, oh, okay. We're good. All right, now I need to know, so we figured that out. Now I need the height. The height, we said, is equal to 2 times the radius, right? Because it's the radius going up, radius going down, so that can has to be 2r. Well, we already know the radius is 2, so that's equal to 6. Okay, so now we've got the height and the area of the base. So now we're ready to do the overall thing. Are you confused? I would be confused if I were a student right now. So now I'm using this formula, 2/3 times this number, there, that's a better place for it. That's the area of the base, 28.26, times the height, and the height is 6. It's a lot, isn't it? It's a lot. So what I'm going to do now is work on my multiplication here. I'm going to cancel the 3 against the 6 and turn that into a 2. I'm multiplying and dividing everything here, so I can cancel. There's no adding or subtracting. Now I can see that I'm multiplying this 2 and this 2 times this. So I'm going to write that as 28.26 times 4. Does that make sense? There's the 28.26. I multiply these two together in my head to get 4. Now I'm going to do a hand multiplication of that. 4 times 6, 24. Oops, I wrote down the wrong one. That's a 4. 4 times 2 is 8, plus 2 is 10. 32, 33. 4 times 2 is 8, plus 3 more is 11. 2 decimal places, 2 decimal places. So, this says, according to my calculation, that the volume of this sphere equals 113.04, what is it, meters? Let me look at the book. Centimeters. Centimeters cubed. I look in the book to see what John wrote, and John wrote 36 pi centimeters cubed. Okay, so this is John's answer. This is me. This is John. He didn't multiply his out, and I did. So now what do I do? How do I know if mine's right or not? Well, I'm going to take his 36 and I'm going to multiply it by 3.14. So I'm going to test his answer by finishing the multiplication, and then I can compare it to mine. 6 times 4, 24. 8, 18. And then a 0 here. 3 times 4 is 12. 4. 9. Sorry, my brain died in the middle of that calculation. Add. Actually, I was trying to do it in my head and compare it to the answer to see if I was getting it right. 4, 0, 3, 11. Look at that. It turned out to be exactly the same as our answer. So, we got it right. Does that make sense? John left the pi symbol in the answer. I went ahead and multiplied it through by pi and found out that ours was the very same. All right, we have 2 more topics to go, you guys. 2, not 1, 2 more topics. Feel free to pause me here, go outside, take a walk around the block, go get a tuna fish sandwich, pet your cat, do something to calm your brain down if you need to, because this is a lot. But don't forget about me. Come back, meet me, and we'll go through 2 more topics. I know that's too much, but that's lesson B. Okay, I'm going to go ahead. Pause me if you like. All right, the next topic for this lesson B, the lesson that won't stop, is surface area. Surface area is, think box cutters. Let's draw a simple diagram to start. This is a triangular box. I don't know if you ever ate that candy called Toblerone. They changed their packaging, so it's not the same anymore. But they used to have a triangular shaped cardboard box for their candy. Okay, so that was a perfect comparison. But imagine this as a three-dimensional object, a triangle here, and then sides that are going back. And we've got some dimensions. When we measure the surface area, we're measuring the outside edges. We're pretending that we're gift wrapping it with perfect gift wrap that doesn't have any overlap. Oh, excuse me. And we want to know exactly how much gift wrap, perfect gift wrap, we will need to cover exactly the outside edge of this box, again, with no overlap. So, once again, it's really helpful to break this down into a list of the different surfaces and then calculate them individually. So here's what I know. We're going to take box cutters, right? You're going out to your dad's workbench or your mom's toolbox, whoever's got this, and we're going to get a pair of box cutters. And what we're going to do first is we're going to cut off the two triangle ends of this. So we know that we're going to have the two triangles. Then we'll have this like open shape, right? You could pick it up and you could look through it and there'd be a triangle at either end that's open, but this would be straight. We're going to cut it, let's say along this edge. We're going to cut down there and then we're going to open it up and flatten it out. Now it's going to have folds in it. The first fold is, so this edge like this is going to now be laying along here, right? So we'll go 5 inches and there will be the first crease. Then there will be 3 inches and there will be another crease, and then there will be 4 inches, and then there will be the other cut end, right? So 5, 3, 4, 5, 3, 4. We flattened out that piece of cardboard so that we can wrap it in our magical gift wrap. And then we're going to put it all back together and it'll be fine. So we have to find the area of these shapes and then add them together to get this total surface area. So how do we find the area of triangles? Oh, we know base times height divided by 2. Right? So now, remember, now we're looking at the triangle itself. In this case, what's the base? 3. What's the height? Well, here's the spider up here. He goes straight down, so that would be 4. Divide by 2. Simplify. And we get that the area of the triangle is 6. Makes sense? But we have 2 triangles, right? That's why I put the 2 there. So let's write another 6 down. That's each of the 2 triangles. Okay, so far so good. We've got this taken care of. Now we need to find the area of this flattened cardboard rectangle that we created. We've got this side. Oh, excuse me. 5 plus 3 plus 4, that's 12 for a total length here. I just added those. Now we need to know this dimension, and that's this. So the area of a rectangle equals the length times the width, which equals, in our case, 12 times 6, which equals 72. And so our total is 84, what's our unit? Look back at the problem, centimeters. Whoops, centimeters. Surface area is an area, so it's squared. Okay, not terrible. We use box cutters to take the ends off and then we slit it open to make a rectangle. Now it's gonna get a little kookier, because instead of using a nice straight-sided object, we're going to switch to, oh, I'm sorry, I didn't put the example on this. This was B6. Now we're going to switch to a slightly more complicated shape. This time we have a cylinder again. Okay, perfectly straight sides, nice circles on the bottom. we find out that the radius from the center to the edge is 4. And we get this. Okay? So we're finding the surface area. We're going to cut it apart. We're going to take off the 2 circles. And then we're going to have this. We're going to cut this and flatten it out. And that is the side piece that we could look through. So that is a rectangle. All right? So we go to our circles first. We want to measure the area of the circles. The area of a circle is pi r squared. The radius is 4, so that's pi times 16. And let's do that. It's 3.14 times 16. Okay, we've done this one a lot lately, so I remember the numbers in my head. 4, 2, 0, 5, 2 decimal places. So each one of these circles is 50.24, and we have 2 of them. Okay. So far, so good. There's our 2 circles. This kind of meandered, so I'm trying to straighten that up. Okay. Now we have our rectangle. All right, we cut that with our box cutters. We know that the height of it is 10, because it's length times width, right? But we need to know this measurement. Well, we look back to our original picture and see, oh yeah, if we had cut it right there to take the circle off and then cut down, right? This measurement is the same as this measurement. So the circumference of our circle is equal to this length of our rectangle, right? If we curled that back up, we could put it back together. So the circumference of the circle, the length equals the circumference, which equals pi 2r. I remember the formula. You have it written in your notebook if you haven't memorized it. All right. Wow, that's crazy. So we have to figure out pi 2r. I'm just going to write it here so it's a little bigger. Pi 2r. Our radius is 4. So that's pi times 8. 3.14 times 8. 25.12. That's just this dimension, and we have to multiply it by 10. Right? Length times width. That's the length. That's the width. I know, you guys, it goes on forever, doesn't it? It's like, when is this problem ever just going to calm down? So now we multiply that 251.2. Okay, that's this times 10. I just bumped the decimal place. This is the area of this, which is this tubular part. Okay, so now we're ready to add. And so I'm mentally lining these up, even though it's a little crooked. I'm going to add the hundredths place first. It's 8. That doesn't have a hundredths place. Tenths place, 2 plus 2 plus 2 is 6. Ones place, 0, 0, 1. Tens place, 5 and 5 is 10, plus 5 more is 15. And hundreds place is just the 2 plus the one I carried, so that's 3. 351.68 is the right answer. Yay, at least we got it right. That's when you want to cry, you guys, is when you get this far and you realize you have a mistake. So it is perfectly reasonable for you to get out your solutions manual and check some of your calculations. Like I would have checked this one before I went on. I would have checked this one before I went on and then added them together so that I can find my mistakes before I've lost track of what I'm even doing. Because if you just keep going, you're like, I don't even remember where that was. So feel free to use your solutions manual, not to copy the answers, but to check your work as you progress to make sure you're on track. Okay, this was example 5.B.7. There's more. B.8. Okay, this time we have the base of a right cylinder. A right cylinder just means that it has right angles in it. It's a good thing. Whoops, this is a 5, not a 6. If you like to draw pictures of geometric shapes, by all means, make that part of your homework. It's somewhat soothing, and it helps you focus on the problem. If it annoys you to draw them, you can just look in your book, because I'm just copying that out of the book. But I find it kind of soothing and relaxing, and it helps me get my head around what's going on with the problem. The base of a right cylinder, that means these are at right angles with the bottom, that's good news, is 10 feet high. Okay, so this is 10 feet from here to here. And that's what's shown. Find the surface area of the solid. Dimensions are in feet. Okay, find the surface area. You guys, now that we're doing several problems with these diagrams, make sure you look and calculate the right thing. It's so horrible to finishing the go. Oh my gosh. Surface area, I thought it was volume. That no one wants that experience. So, all right, so we want the surface area, so that means box cutters. So that means we have this mailbox door shape. Some people think this looks like the top of a toilet. I mean, I can see it, but I refer to it as a mailbox shape. To me, that looks like a squishy mailbox flattened on its side. If you stand it up, that would be the little door that you open. Old-fashioned mailbox. Most mailboxes don't look like that anymore. Okay, so I'm gonna find 2 of these, and then I'm gonna find this long, skinny piece of cardboard that wraps around the edge, right? So this is this. We get a more detailed diagram so that we see what that looks like, because we have to find the area of this shape. Okay, so to find the area of this shape, we're gonna have this rectangular square shape, and then we're gonna have the semicircle, right? So it's these 2 added together. So the square, that's gonna be length times width, and this is 5, and this is 6. Okay, so it's gonna be 5 times 6, and that's gonna be 30 units squared, whatever we're dealing with. Okay, the semicircle, we want the area of that, so that's pi r squared divided by 2, because it's a half. This is a circle, but it's a half circle. That equals 3.14 times, whoops, I forgot the 1. 3.14 times the radius, which is 3, but it's squared, so that's 9. And we divide it by 2. Okay, so I'm setting up I'm imagining the pieces, I'm setting up my calculations, and I'm plugging in the numbers, formulas, numbers. Okay, I've got that one carried through. Now I need to do the math on this. What I'm gonna do is I'm gonna take the 3.14 and I'm gonna multiply it by 4.5, because 9 over 2 is 4.5. So I'm going to simplify my math, so I just have one step by dividing those in my head, and now I'll multiply by hand. 5 times 4 is 20. 5 plus 2 is 7. 15. 4 times, let me put the 0 in. I skipped that step of writing it out, and I want to be clear about it. 4 times 4 is 16. 5 plus 1, or 4 plus 1 is 5. And 12. 0. Just double checking. Yep. Just a second. I feel like I've made a mistake somewhere and I can't. Nine times pi divided by 2. Okay. 1, 2, 3 numbers behind the decimal place. 1, 2, 3 numbers behind the decimal place. So this is 14.13. Okay? When I add these two pieces together, I'm getting the whole of this, and that is 44.13. That's the area of these flaps. Each. This is 1. So I need 2 of those. Right? Okay? Now I need to find this part. All right, so let me draw another line. This is so messy, you guys. I'm so sorry. Now I need to find this rectangle. Okay, I know that, I'm going to draw it again here so I can write on it better. I know it's 10 high. I know that this dimension is the same dimension that goes all the way around the edges. So if I can find all the way around the edges of this, then I will have that number. So it's going to be, I'm going to start here and go around clockwise. 5 plus 6 plus 5 plus the circumference of a half circle. So it's going to be circumference of a half circle equals 2 times the radius, 2 times pi times the radius divided by 2. So it's pi times the radius, so it's 3.14 times 3. Woo! I add all of these together, and I get 25.42. I multiply that by 10 to get 254, sorry, 0.2, oh, let me write that again, 254.20, that's just moving the decimal place there. Okay, that is the area of this whole thing. So now I have 3 pieces I need to add together. 44.16, 44.16, and 254.20. Oh, I copied these wrong. These are 3s. Sorry. So that's a 46. So our final answer is 342.46 feet squared. And we still have one more section to go. I have to pause, and I will come back in a follow-up video and do the last section. I know, just to make it more complicated. I'll clarify your homework in the final section too. I'll be right back.